And welcome to our YouTube viewers to the Daily Space Weather. I'm your host, Dan, aka Smash-a-Mash, coming at you from the Smash News Network, least busted name in news. And we are looking at the closest star right here. Keep in mind, this is in 3 different wavelengths. This is some composite imagery here. It's showing you 211 angstroms, which is normally sort of an orangish color. It's showing you that in green, 304 in red as it normally does, and 171 in blue instead of the gold color. So, an exciting couple of days here, as I believe there are 2 coronal mass ejections headed toward Earth. We'll get to it, as well as talking about sunspots, coronal holes, magnetospheres, and more. First, the earthly geospace. Here's the magnetohydrodynamic pressure in nanopascals modeled around planet Earth, out to about 12 Earth diameters for the last 4 hours. And we see a pretty consistent pressure here and a pretty consistent solar wind. If you're wondering, those things are directly related. So no major striations here in the past 4 hours to the Earth geospace. Ground magnetic perturbations are similarly predictable here. Geospace delta B, it's showing nanotesla as the scale here. That's magnetic flux density over the past 4 hours. And it's geomagnetically calm conditions at the moment. We'll get to a bunch more data. So hold on to your hat. Some exciting stuff about coronal mass ejections coming. The planetary K index here at 2 for the past 21 hours. Each bar representing 3 hours there. Planetary K index, it's a KP2. Geomagnetic calm conditions. And going to the real-time solar wind, we do see a rising here of the solar wind density. We are now up to over 20 protons per cubic centimeter. Solar wind speed still quite low. Not as shockingly low as it was yesterday, though, in the 260s. It was on our thumbnail. Anyway, now we're back over 300. But we're seeing an increase in the solar wind density here. It looks like a long shock front for a coronal hole high-speed stream. So not sure how high that will go. I don't think it'll go higher than 30. But we'll see what happens. It looks like some early arrival of some coronal hole high-speed stream protons. The shock front, the density wave at the front of a typical coronal hole high-speed stream. Next to GOES magnetometers over the past 3 days, pretty smooth here. That's the readings from the GOES 16 and GOES 17's magnetometers. They're located at a near equatorial geosynchronous orbit. Next, the heliospheric current sheet. Earth is in a North Pole current sheet shown here in green. No frills there. No expectation of that changing anytime soon. Just keep in mind the magnetic environment can change suddenly with basically no warning. Here it is from a line-of-sight perspective, also showing the solar magnetogram. We've got 4 major sunspot groups on the Earth-facing portion of the solar disk. They're all beta-gamma class sunspot groups. Here is our coronal hole plot as we move into the realm of coronal holes. So a very large area here of coronal hole activity. It's North Pole oriented. And another interesting fact here is that the North Solar Polar Field is still largely constrained at the North Pole. So Solar Cycle 25's solar polar field reversal process is taking quite a long time here. It's sort of behind schedule of where we would expect it to be. And let's move on to take a look at coronal holes visually. Here's 193 angstroms from the Solar Dynamics Observatory. And that leading portion of it there is quite well defined. Some active regions behind it there. And let's move into sunspots. Again, we had coronal mass ejections. We'll get to it. So as far as sunspots, we've got 3006, 3007, 3008, and 3009. Just go clockwise, and there you go. 06, 07, 08, and 09. They're all beta-gamma class sunspot groups. We've also got a new sunspot down here. I think it's this one. That is already a sunspot. And there's another active region rising up here. Let's take a look at it on the 1700 angstroms wavelength. So we've had an increase in the radial flux now. The radial flux now up to 133 solar flux units. Perhaps watch our BitChute exclusive video for the day. There is some additional coverage about space weather, earthquakes, and volcanoes on that video. Next, I would invite you all to follow us on Twitter, twitter.com/smashomash. Thanks to everybody who has. If you don't like Twitter, I don't blame you. It's certainly not fixed. And again, if you think Elon Musk is going to be some kind of a savior of censorship and big tech and so on, I would say think again. I see no difference. It's just as pathetic as it was before. Let's talk about HIPAA, the Health Insurance Portability and Accountability Act of 1996. Did you know that people not involved with your health care and the administration thereof have no right to any of your protected health information? Well, it's true, folks. Anyway, of course, you can sign whatever kind of contracts you like. You can have all kinds of private deals. But in any case, HIPAA did not evaporate in the year 2020. This is our best-selling product on our Redbubble shop. HIPAA, the Health Insurance Portability Act, the Health Insurance Portability and Accountability Act of 1996, because those not responsible for your health care and the administration thereof have no legal right to any of your protected health information. Again, we are also on BitChute. There is an exclusive video over there as well about space weather today. Normally our meteorology segments go there. Today's meteorology segment on YouTube. We also regularly stream live to Twitch. And there would be at least one Twitch live stream. We streamed yesterday for over 9 hours. Thanks to everybody who tuned in. If you're a bigger channel on Twitch, please host the content. Thanks to everybody who has. If you want to support the channel via subscription services, consider becoming a member of the Smash Team at smashomash.com/SmashTeam. There is complimentary merch for Gold annual paid-up subscribers. All Gold subscribers have the option to obtain an @smashomash.com domain email address. Most basic names are still not taken. The silver level is only $2.99 a month. There's also a bronze level that's free if you want to see all of our video content major releases in one spot. Head to smashomash.com/SmashTeam and click on posts. So welcome to the Neo Renaissance. You can find our social media links. Consider giving Smash staff a raise by becoming a patron or a member of the Smash Team or picking up merch. You can find a link to that as well right there, the Smasho merch link, right there on the homepage at smashomash.com. And let's get back to some relativistic protons here. So we've seen some radio blackouts as a result of relativistic protons. One of those solar flares was associated with very high-speed particles. So here's your radio blackout scenario. And you can see some polar radio blackouts here are just subsiding now. So typically, this is an interesting moment right here, because typically when we see radio blackouts, they're caused by photons. Solar photons attenuate the D layer of the ionosphere and cause radio signals to just go flying out into space instead of refracting back down to the ground. Protons cause radio signals to be attenuated at the poles. And again, you can see that radio blackout now subsiding at the polar regions as we see the proton content dropping here. A perfect example of photons versus protons and their effects on planet Earth. Keep in mind, folks, X-rays are filtered out by the mesosphere level. And watch our bonus feature segment. That'll be a live stream on twitch.tv/smashomash. So 2 M-class flares in the past 24 hours, also some large C-class flares. This larger, long-duration M-class flare is the one that was responsible for sending those solar protons. Peak flux of that was around 1850 last night. That's universal time. And let's take a look at the flaring profile here. So here's the imagery of yesterday and today. Again, 2 significant flares here. And that one there is the one that sent the relativistic particles. So check it out, folks. We've got a sunspot group that's not even visible on the earthly portion of the solar disk, producing a large flare, an M-class flare, and sent relativistic particles all the way to planet Earth. So those particles were traveling at a significant percentage of the speed of light, hence the term relativistic particles. Yeah, that was a pretty major flare there, folks. So great imagery there in 131 angstroms. The SDO imagery there. And there were coronal mass ejections. We'll get to it. First, a star chart. The planetary pileup continues every morning. Saturn, Mars, Jupiter, and Venus rising ahead of the sun. It's a great day for morning. It's a great couple of months, really, for morning sky viewers. And let's move on to a planetary forecast. Let's go ahead 1 week as we're approaching another full moon. Here's where things will be in a week. All the planets gathering on one side of the sun are enough to freak people out on YouTube and convince them that the planets are going to kill us again, even though it happens over and over again, and the planets don't kill us. We're going to go over cosmic rays today, briefly. We're going to look at some viable, reliable cosmic ray monitors. So we see a minor downtick here at Apatity over the past 30 days. Barentsburg, a slightly more serious downtick over the past 30 days. No surprises there as Solar Cycle 25 ramps up. Let's go a little farther south, much farther south, really, to Athens, Greece. So Athens, Greece is quite a bit more flatlined here, but a slightly downward trend there at Athens as well. Here's Mexico City's Cosmic Ray Observatory, and a slight downtick at Mexico City to go a little farther south. And now let's go back north to Oulu, Finland. One of the best cosmic ray monitors. It's got data all the way back to 1965. And a slight downtick there at Oulu, Finland. Let's go as far south as we can get, DOMC and DOMB Antarctica. Major downtick at DOMB Antarctica, and a major downtick at DOMC Antarctica as well. No surprise there to those understanding the relationship between solar cycles and cosmic ray flux. When we see a lot of sunspot numbers, we see low levels of cosmic ray flux, historically speaking. So that's the cosmic ray outlook. And we'll close things out with coronagraph imagery from Lagrange point 5 at Stereo A's coronagraph and Lagrange point 1, the Soho Lasco C3. So we've paused this here around 2100 because this one's sort of in the earthly vicinity. Most of the ejecta looks like it will miss to the west, but I think there is some that will actually strike Earth here. So that is a gigantic CME there, as you can see. It's sort of in the earthly vicinity, but much of the ejecta expected to miss to the west. I think there is some ejecta headed our way, though. I'm expecting a CME impact in about 2 days and another one in 3 days. So we covered that gigantic one on the other side of the sun. If you want to see more information on that, watch yesterday's YouTube space weather video. But there's the situation. I think there are 2 CME strikes on the way. Also, a coronal hole wind stream is sort of in the process of arriving now. Let's bring those back and let those play through before we close out today's YouTube exclusive daily space weather video. In any case, thanks for tuning in, YouTube viewers. Thanks for putting up with the pathetic censorship, spam, nonsense, fraud, and propaganda on the platform. I don't know how it became such a disinformation platform. I don't know what happened. But we're confident that it will be fixed. Because if it's not fixed, well, it'll just continue self-destructing, right? So don't use self-destruct. And remember, the Health Insurance Portability and Accountability Act of 1996 is still a thing. So we'll see you soon. Thanks for tuning into the Smash News Network. Least busted name of news, and may that solar wind be at your back.